Hi, today we will try to solve linked list problems. Let me share my screen. So I'll try to solve reverse linked list first, which is easy. Then palindrome linked list, which is a little bit more complex, and rotate list, which is medium. I did before reverse linked list. I just reset this code, and yeah. So main idea is to reverse it in place. Obviously, right? We are not. Could you implement both? But iteratively or recursively could you implement both? Okay, so I'll try to reverse iteratively because this is what I've done before and I kind of know how to do it and I just want to practice it more. So idea is like we have items like this, right? And our goal is to okay, let's try to draw. It's kind of like I'm not sure if drawing is a good idea because you cannot draw if you have like an interview, if you have a like code sharing screen. But the thing is, what we will try to do, we will delete this link, point this here, move next. So this is what link on head we have, right? Head. We move to the next. We keep previous link. So we keep previous because we need to restore this connection and so on. And after we reverse all links, we were gonna have practically this list. So in order to do this, we will declare a previous and we can say while head, right? And we accept head previous will be no, we have to do head next equal previous. Do we have a store head next? I think we have to store it because it's pointing on 2. So if we assign head next to previous, or let's say next, and then so this is we fix this link and then we moving forward, right? Head equal head next. Something is missing. And then previous we assign head. So let's see this again. If we assign value next here, Let's draw again. So this is head. We assign next here. Then we assign head next to previous, which is none, which is okay. Then we move head here. We move previous here. And then on next iteration, we assign next here. Then we assign head to previous. Then we move previous to head. Yeah, this should work. Let's see. Nope. Oh, invalid syntax while. And at the end, we must return. What we return at the end? Head will be empty, return previous. Okay. Oh. Yeah, oh, it works on empty list. So why it's not working? So we assigned. So this is pointing on head, right? And we assign head next to previous. But we are not storing head next. Oh, we are assigning next value to head next, so to become head next. Become head next. Head next. Our previous is none, and we are pointing head next here. Then previous equal head. Pointing here. Oh, we cannot do this because we're pointing back here. Yeah, so we just, yeah, we assigned next. Yep. Okay. Wow. Yeah, I probably have to do it like another 100 times until I'll do it flawlessly. Yeah, let's move to another one. So palindrome. Palindrome is a little more complicated. So I quickly look on how to do it for one space, because my initial thought was like to put every half palindrome into stack, and then as moving forward, pop from the stack and check. But we need all one space. And I checked on solutions, and most popular solution is to reverse list. So here is the idea. Reverse list until half of the size. So we're gonna have like let me draw. So we're gonna reverse this list into 2.1, right? And we will have pointer here, and we will have pointer here next. So after reversing, we should have 2 pointers. First pointer, which will be reverse pointer, and second, which will be like slow pointer, right? Then we move with same speed, but over this list here and this list here, and we compare values, and values must be the same. If values are not the same, we return false. If we reached end of the list, either one is end, then we return true, because so this is the plan, and this is why I wanted to solve a reversing algorithm, because reversing will be here. So reverse list until half of a size, and then we have 2 pointers, one pointed at middle reverse list, reverse half, and second on non-reversed. And 3 moving all all pointers moving 2 pointers, compare values, and if not equal, return false. Yeah, so what we're gonna do, we're gonna first reverse. So we're gonna say while. So we let's create 2 pointers. In order to detect middle, we create 2 pointers, slow and fast, both pointing to head. And while head first, next, we gonna reverse, right? So reverse, we have to also introduce previous, which is none. So we assign next to slow next, then slow next, we assign previous. Right? So next, yeah, it's a good practice. So first, we assign here to previous will be here. This is our slow. and this is our next. So what we're gonna do, we're gonna assign slow next to previous, right? Then we move slow to the next, and previous to the slow. Yep, there's two adjustments we have to make. So we assign previous to the slow and slow to the next. So here at the end, we're gonna have slow pointed exactly on the middle reverse list. So what we want to do then y slow wait, but and we return prev. So prev points on, this is my assumption, I'm not sure, but this is what I think will happen. Print points on, prev points on reverse, our reverse head, and slow points on follow head. If this is follow, this is reversed. So then what we're gonna do, we're gonna while slow you can say if slow value not equal prev value we return false. And then we assign slow to slow next, and prev we assign prev next. And that should be, that's the end, we return true. Yep. Okay, now next fast, next. Bum, bum, bum. So if empty list empty, attribute next. So on empty list we return what? Then has a return true if it's Panjo. Oh, okay. So if I can say if had next, if not had next, I can say return true, because one is always palindrome, right? Yes. Oh, okay, so at some point because we are not moving fast, next. So we can say fast Next, yeah, we're not moving fast. But ship must be wild fast and fast next. What's this? So should I assign only if like this? I do not understand why it's failing, honestly, but let's just okay. So at some point, previous and slow must point on 2 and 2. Let's print them and make sure that they're pointed. That. So we print slow. So first it will be reverse, and this will be next. Oh, I'm not sure if it's slow or it should be next. Next? Yeah. 1, 2. So previous is not correct. So it could be slow and next. Okay, let's try. So let's try assign next here. And we have slow here and next here. Oh, slow may be equal next. Yep, it doesn't matter. So in this last operation, we assign slow to next. Oh, it's not a good idea. Let's also call it next one because next is a keyword. So we assign slow and I'm curious what is slow. next. Well, it's hard to tell because they're all one. Dominating back. Is it time for print function? I think it's time for, but we don't know. See, this is like tricky example because we have a okay, let's do dry run. So we assign so this is slow, previous will be none. We assign next to slow next, which is here. Then we assign slow next to previous. Then we assign previous to slow. And then we assign slow to next. Right? And in this case, also we have fast pointing here, fast pointing here. Then fast will be pointing to next. So pointing to here. And then hopefully we will do another run. And we assign slow to previous. Next one to here. We assign slow to previous, change here. Right. And then we move next next here. Slow next to previous to slow, and slow to next. So actually slow will show us here, and previous should show us here, right? Right? Let's make a screenshot of that because I'm not sure. So slow is pointing here, previous, it should be 2, why it's 2, 1, why it's 1, 2, I don't know. So let's do printing, right? Let's do print. I made it a couple times while age. Print. Oh, maybe we create function string like empty string while age we add to string age well, and then age next. I can actually define it right inside this function. I don't have to do separate functions. And let's print what we have for preview and what we have for I would call it differently. Okay, so let's try to print it only. Yeah, we do have to do graph. All right, so it prints nothing. Oh man, why? Okay, something wrong is here. obviously it's gonna print nothing. Oh yeah, we have to move one more. So this is 2 to 1 and this is 1. So my question is, did we overlap? So did I overlap? So previous is 1. I did not. So I have to move one more time. Then one more rotation. While not. Can I do this? No, it doesn't matter probably. So because fast, next we stop in here. So fast will be here, slow will be here. So if we have like, oh, the thing is, if we have odd amount of elements like this, right? That will be perfect because we stopped here. So how about if I slow and slow next? Oh, it probably shouldn't do it because I have 2 to 1. And 2 1. Yep. So let's try to do one more rotation. I'm not sure. Yeah, I have to count somehow amount of I think you just count amount of elements. And let's say this was a 0, element 0. And we just print count. And it was just 0, so just one rotation. Yeah, this is what I thought. So first, next, and this point here. Okay, let's try to do one more rotation. And all right. So let's define next one here. Could be because that wasn't defined. Yeah, I can use this condition. So if fast next node, I can just say, yeah, if head return head value equal head next value. Yeah, so if we have just one, Another common case, if had not had next, we just return true always. Okay, this is the thing when we have three of them. So I need to have some kind of indication here. See, this is 0, 1. So if it's 3, this is not required. I just so this is only if we have even amount unlisted, even amount of elements. If we have all the amount of elements here, we don't have to move to next. How can I? Can I print fast? Maybe if I fast and fast next. Maybe I can detect that by oops. Looking at fast and fast next. Okay, so next is none. So I can say if not fast, then I will add it, right? Right? Yeah, almost. This is working, but this one is not. And I did over jump. Let me print here. So fast next is always the thing, right? So here or here, here or here, there is the same. I cannot detect it. So should I print C? And C will be 1. Here C will be also 1. Okay. Yeah, I feel like it always should be like one extra step. See, when I run, I have this 0, 1, which is back. So I can say, can I say like count? Count is 1 probably everywhere, right? Count 1, count 1. I like that this is perfect. And this is overshot by 1. So I should start comparing not from slow, but from slow next. Or right? So this is previous next, slow. Let's do some abstract printing. Yeah, so counter 1 in all those cases. What the main problem is, let's write it down. How to detect. So problem is how to detect amount of nodes and exclude the root node in middle node when amount of nodes even. Not odd. So when we are iterating through this, our counter is the same. I wonder if I comment this, will it work for odd amount of cases? Yes, for even, but not for odd. So this should be only if we moved, but this counter is 1, and this counter is 1. We moved. We are not moving to the end until we count in fast moves. And also we need to know. So this next node, fast mode. So fast pointing on 1, which is last one, and next is none. Here is the same situation. It stopped at the same point. So maybe I should count only if I have it. Now counter is 0. This counter is 0 too. Can I also print like if slow? We are reassigning previous to slow, right? So previous is slow is the same. How it's possible that they are? I'm using them here. Should I use, I don't know, slow maybe next? Yeah, so apparently previous is slow and the same node is just pointing. No, it couldn't be pointing the same different direction, right? Can I hash it? Like if when I'm printing here, I wonder how can I print how can I print maybe hash of object. So I will know this is the same node. See, this is node 2, and it's the same node as this one. So it's not reversing properly. Like this is okay. I'll do the whole thing after that. This doesn't work in any way. So what I'm trying to do, I'm trying to get like correct reversed list for here. This is 21. which is 2, pointed to 9, and 93, which is 1. This is 25, which is this 2 pointing to 49. And this is how it's supposed to be. So one last rotation is kind of what we need. But here we have 0 pointing to 1, which is correct, and then another 0. So and we have while slow. Maybe we're just comparing two zeros, but what we need to do should we do preview? Yeah, we got error. So we have 0 pointed to n, to 1, correct, and we have 0, this pointing on 0, and we need to compare, but we have to move preview. And it's not counter, right? The question still remains, how could I detect counter 0 amount of okay, it's probably not like very good idea, but how about we create functions that detect lengths of this? I know it's like act of desperation. Yeah, so we create counter, and we return the thingy, and we have this here. So, and the beginning we can create, we can just question, is this printing moves? So I don't know if function move pointer inside. No, I don't think so. So this is a 3, this is a 4. So now, how about we say if counter we move from we move slow or we move previous? We move slow. Move slow equals slow next. Previous. Yeah. Okay, romance again. This time is 5, right? Whoa. So the thing is, maybe I have to move here only if it's 0. Yeah, something wrong. Okay, I guess it's good enough for today. I will pick up tomorrow from the same task, rotating linked list, and this one. We start working on this one and thinking how to do it better. But that's it for today. Thank you for watching. Bye.